Yeah, so may I kindly request to please confirm that whether I am audible and my slides are visible and it is also floating.
Yes, sir,
Yes, it
it's
is audible, visible. Please go ahead.
Okay, okay. Thank you so much. Thank you. Yeah, so a very good afternoon to all the members and participants and esteemed members who have presented in this very aspiring FDP, which is application of artificial intelligence and machine learning in electrical engineering. So I guess even I was also attending in past 2 days. Even I have also attended few of the FDPs, and because of a very tight schedule, I cannot attend all the sessions which has been discussed by experts. So whatever I have attended so far, I think I have heard enough of AI, what is AI, what is ML, what is deep learning. So all this, very basic classification and all its definitions, its meaning, its
sorry to
what
interrupt you,
this
sir.
terminology means.
Hello, sir.
Yeah, yes.
Sorry to interrupt. Yeah. So please switch on to the slide mode.
Okay, sure. Yes, whether it is in slide mode now,
Yeah, it's okay.
it is right.
Yes, now it's okay.
Thank you.
So please
Yeah,
continue.
it's yeah, okay. So I will not stress much on the specific definitions of AI and ML and deep learning. I'll just discuss that how these, advanced technologies are paving the shape of our life and how specifically in power systems it can be utilized to detect the faults, which are one of the major aspect which has to be tackled very carefully. And also, as we are technologically advancing in every other day, in every other aspect. So as far as power systems are concerned, we have to have this AI based leveraging technology which can give us some additional kind of hands on setup, so that the accuracy can be improved, the time response can be improved, and along with that, the precise detection of fault can be achieved. So, in line with this slide background, I will discuss that what are the contents which I am going to cover in the time slot which I have been allotted. So, we'll start with the very basic introduction. We'll also discuss some types of faults, and which is followed by the comparison in approaches, which is specifically in line with our conventional approaches, followed by the advanced new age AI based technologies, and how we can detect the faults by employing some AI methods, followed by its actual real world applications, and which specifically means how we can upsurge the technology from lab to market aspect. So that also we will discuss slightly. Along with that, what are the tools and platforms we can use, followed by its specific accuracy and contribution based on some different technologies. Along with that, we'll I'll try to throw some light on the comparative analysis, and finally the advantages and some of the cons which are associated with the artificial intelligence method. And this will be the presentation will be expected to be concluded by the research trends which are going on in the field of AI based fault detection in power systems. So with this, we'll start with the presentation. And so we can say that from past 3 to 4 decades, the power generation, the transmission and distribution is somewhat isolated, and it has been centralized in centralized structure. But from last 5 to 10 years, if we analyze, especially from past 1 decade, there is a rise in this DERs, which we abbreviate as distributed energy resources based power generation. And the power generation is coming from very disparate locations. So we have solar, we have wind. In solar also, we have rooftop solar, we have residential based setup. So all this power are coming. Along with that, solar and wind are considered as two of the most prominent renewable energy resources. But in line with solar and wind, there are other renewables also, like small hydro, which has been recently categorized as renewable technologies only, and if we go by the large hydro, it is designated as a conventional power generation, but small hydro can be clearly considered as a renewable based power sources. So that is also coming into the picture. Then fuel cell technologies are also there. So cumulatively, if we see, there are a lot of DERs, distributed energy resources, which are coming into the energy mix. And as we are aspiring to involve more and more power generation from these renewable energy resources, the important thing which has to be considered is when it is integrated with the utility grid, then the whole dynamic of power system is going to be not partially, but almost completely, it has to be changed. So for that, we require the infrastructure upgradation, because completely, changing the dynamics of power system is not possible, but upgradation is possible, which can only be happened in phases. In short phases, it can happen. So considering this variable nature of renewables, the problem is we have the prediction is the most important thing. It has to be predicted accurately. Once the prediction is accurate, we can have a schedule and dispatch scenarios, which is carried out generally by the state load dispatch centers and regional load dispatch centers. So these people are responsible to carry out those kind of scheduling and dispatch. But for that, prediction is very much required. So in that way, also AI is going to play a major role. Now, since we have talked something regarding DERs, this is followed by the bidirectional power flow. So bidirectional power flow is also one thing which is happening now because of this variable nature of DERs. And there how the smart grid is evolving, the whole infrastructure is evolving. Also, if we see our conventional approaches, which I'm going to discuss a bit, is comparatively slow and rigid. So the inclusion of these variable loads to make our power system modern is in transition phase, and due to these rapid advancement, we have to involve these non-conventional sources in the energy mix. And this monitoring and control of these variable renewable energy resources are where we have to merge, we have to integrate it as a single entity, and then only we can interface it with the utility grid. So this is the very brief motivation for this particular topic. And as we are succeeding to our next slides, we can discuss that this will also going to create a lot of problem in terms of the fault issues. So basically, the AI are transforming our power system protection. When we include this kind of technology, this kind of new age artificial intelligence technology, it is going to be upgrade itself from reactive to proactive by accurately detecting, properly classifying, and predicting the faults with speed and precision. So these two aspects are going to play a major role whenever we are talking about AI-based fault detection in power systems. So the importance of this strong intrusion detection systems and advanced cybersecurity measures, because see, these days people are talking about microgrids, and there is one more very important concept which is going to evolve our power sector completely. I think many of you have heard of it, because that is one thing which I wanted to emphasize, because in that research area only I'm working from last 5 to 6 years, couple of years. So that is virtual power plants. So it is actually a upgraded version of microgrid, and the majority of difference between the virtual power plant and microgrid is it is always grid connected. So microgrid, we are having one option that we can island our system. Islanding is possible. That phenomena is possible. But virtual power plant is completely grid connected. It is always connected to the grid. If because of some reason the grid is down for particular time and it cannot fulfill the power requirement, then we can have some or the other kind of a storage system, storage based, battery based energy storage system, or some other kind of energy storage system, so that the power can be fulfilled. So why I am emphasizing on that is these microgrids and virtual power plant are very very technologically advanced thing, but cyber security measures and cyber security issue is one of the most important thing which has to be tackled if we are discussing any of those kind of advanced technologies. Then only it can be it can be inclusive in all aspects. So to have some reliable grid operation and to have the prevention of more significant interruptions, that those cybersecurity measures are also needed to be taken care of. So there are some of the traditional approaches, but as the machine learning and deep learning concepts are evolving day by day, it is expected to prefer and to tackle the issues in this dynamic smart grid environment. So also considering this particular cyber resilience for to ensure the impeccable operation of AI-based techniques are required to advance the smart grid network. So we'll discuss something about faults. I think most of you are already aware, but since this is the most important part of our topic, we will emphasize a bit on the types of faults. So as we discussed that power systems are very complex in nature, and its functioning becomes quite vulnerable when it comes to these kind of faults. So these are some symmetrical faults in which line to line faults are there, three-phase line to ground fault are there. Those are considered as symmetrical faults. These are followed by the unsymmetrical faults in which line to ground are there, line to line is there, double line to ground faults are there. And if you see in unsymmetrical fault, the majority of the faults are categorized as line to ground faults based on their occurrence. So it is roughly around 70%. So these are something about symmetrical and unsymmetrical fault. This for transformer are concerned. So the other aspects of faults will include open circuit fault, short circuit fault, and incipient fault. So these incipient faults are immediately not that much intensive in nature, but if these faults are not taken care properly, so over time it has the tendency to become or to transform itself into a major fault, which will lead to a major damage to the particular system or the particular equipment. So since incipient fault will not do immediate damage, but the extent of its intensity can increase if it is not taken care of within the time limit. So these are also important. So we'll discuss something about the conventional method, that how we are so far carrying out the fault detection method based on our traditional system. So it is impedance based method in which we are going to measure the impedance of transmission line. But as far as those faults are concerned, but the problem is problem which has been encountered is it is quite time consuming. And in power system, the things has to be taken care of, not minutes also, I must say. It has to be within seconds or milliseconds. So then only power can be restored and can be the power supply continuity can be carried out. So this is one method. Another method was fundamental frequency component based method and traveling wave method. So this is also one method, but in this particular method, more human involvement is required. Manual intervention is also required in this particular method. Along with these two, there are digital relay based algorithms, based advanced algorithms, but as if we compare with the previous two, the detection capability is quite improved in case of this third one, digital relay based algorithm. So these are the very basic ways to how we are detecting the fault through traditional approaches. So we'll see that how AI is going to transform it, and what exactly the role of AI is playing in this particular scenario. So as we discussed that it is power system, this whole structure is very complex and it is particularly vulnerable when it comes to the mentioned faults. So usually AI-based processing will start collecting the data, because these systems are data hungry, as we know. The more data we feed to it, the more decision making the particular system can carry out, and therefore these systems are also called as data hungry system. So if you give it a less amount of data, it will again give you the result. It is not the point whether it is going to give you the result or not, but the precision, the accuracy will be questionable. So that is why we have to increase the amount of data. The more data we can give, the better result we can expect in return. So the first process is the first step is the pre-processing, which is followed by the acquisition of this data. Then the most important the most important thing is to detect the type and classify the specific fault. So if it is line to ground, the detection must be line to ground only. So the accuracy is expected to be more than 99%, because in my opinion, there is no such thing as 100%. Even we can be accurate like 99.99%, but 100% accuracy is again debatable. Not saying that it is not possible, but that is something which needs further discussion. So detection should be 99.9% correct and followed by its classification, so we can determine that which type of fault has occurred. And finally, once these two steps are, these are the broad classifications of AI based processing. Once this is completed, then only we can see that how we can identify the location of fault. Once the fault is located at a particular place, then only it has to be rectified, if not mitigated completely. And this is followed by the restoration of power supply. So these are some three broad, scope of AI-based processing. So we will move on to next slide, in which I'll be going to discuss the AI methods for fault detection. So first one is, we'll discuss about fuzzy logic. So fuzzy logic is usually implemented in detection of fault, in which there is a reduction in uncertainty while measuring the fault. So there are uncertain natures of various resources which I have already discussed. But when it comes to the fault, that particular thing has to be taken care of. So fuzzy logic, based on that, we can have this particular freedom with us. This is followed by the machine learning approaches, in which mostly you might have heard of this decision tree method. It is a broad classification, and based on that only the random forest technology can be applied. It is a sophisticated optimization and an algorithm method. So based on that, we can determine the fault. Along with these, there is another which is called SVM. The abbreviation is support vector machine. So these two are broadly classified under the category of machine learning methods. Now this is followed by deep learning. So these are relatively advanced method as compared to machine learning. So in the subsequent slide, I'm going to discuss one graph in which the accuracy percentage is also shown. So we will discuss in that particular slide. So coming to the DL, deep learning, there is waveform-based method of fault classification, in which CNN is there. So I think we are aware of CNN. It is convolution neural network. It is the advanced function of ANN, artificial neural network. And this is followed by the LSTM, long short-term memory-based method, which is generally sequential-based method of any fault prediction. Apart from these three, we can have some hybrid kind of technologies, which is the graph which I have mentioned, which we'll discuss a bit. So that particular thing also, when we combine these methods, when we combine this ML or DL method, or if we combine the combined attributes, we can actually leverage its full capability. And therefore, the hybrid methods can be a combination of this, either machine logic or machine learning or fuzzy logic. And this is followed by the additional expert rules, in which the precision will be enhanced somehow to a greater extent. So these are some of the AI-based techniques, and now we'll discuss about the tools which are required, or platform which are required to which are powered by the AI techniques. So these are machine learning, as I have discussed, from the conception point of view, it is support vector machine, it is random forest, it is KNN is also there, which is K nearest neighbor. And in deep learning, there is advanced version of machine learning, which we have already slightly discussed. It is convolution neural network and radial basis neural network. This is followed by the there is one more term which I have mentioned, FL and RL. So the abbreviation of this is federated learning and reinforced learning. So these two are more suitable whenever we are having some imprecise data, or when the data precision is comparatively less, and also it can take care of the uncertain nature of these faults. So these are some of the conception based requirement for the tools and platform. Now, if we see in broad classification, these are presently the percentage share of AI-based techniques in which, if you see this pie chart, the majority has been carried out. It is roughly 34 to 35%. The majority will be, carried out by machine learning based method, which is followed by another 31 percentage. These all are in percentage here only, which is deep learning. This is followed by the unsupervised learning, which is 15%, and hybrid techniques, in which there must be a combination of either of these two technologies. So it is currently, the share is nearly about 20%. So these are the shares of these techniques. Now, if we go by the approach, or specific approach and accuracy in the fault detection, we can see in this particular graph that if we go by the percentage accuracy, there is a scale of 0 to 100%, and conventional method can almost detect the fault in 80 to 85%. This is the right block. I want you to just pay attention. The right block, the light blue block, conventional based method, which we have discussed. So it is going to give the accuracy nearly 80 to 85%, but I think not more than that. Coming to the machine learning process, it can give the efficiency of almost 87 to 90% machine learning. Deep learning is an extended form of particular AI technology, which can give almost 92 to 95%. But hybrid technique, which I have been mentioning, the combination of the amalgamation of these technologies can give with an accuracy of almost more than 95%. So what I have referred is it is showing some 95 to 97%. So I think it is pretty decent. And even if we see from the conventional approach, it was roughly 85%. So from 85, we have reached in terms of accuracy almost 97%, not more than that. And it is expected that in the coming time, this remaining percentage will also going to get improved. So yeah, so coming to the comparative analysis, in which AI detection versus conventional approach has been drafted, and there are few parameters which I have mentioned in this slide. So if we see the type of maintenance, the conventional method I have mentioned, as I have mentioned, it is more and more with respect to the human intervention or manual intervention. So that is particularly required. Round the clock supervision is required, and lot of human intervention is required in that method. But AI based detection deals in the self learning approach. So automatically, as the grid condition is keeps on changing, it is not constant, because mostly if we see the conventional approach of power generation, we know that how much power exactly we are, or almost approximately we know that how much we are generating, what will be our requirement, how much we have to transmit from which point to which point, we know. So we can maintain the inertia of the system. That is one thing which I want to mention here. But as more and more renewables are coming into the picture, the inertia of system will get disturbed. And to maintain that, we have to make such system, such capable kind of holistic system, which can continuously, adapt itself to the varying or changing grid conditions. So that is why it has been mentioned that self-learning, it can, based on the data whichever we feed, whichever data we give to the system, it has to be auto-tuned based on the changing grid conditions. So that is one very important thing which I wanted to mention in this presentation. Now we'll go to the next parameter, which is its ability, or we can say it as a capability. So conventional method, the ability is of course very limited. It is not beyond a certain extent we cannot go. But as AI based detection or self learning in nature, the ability of it is very high. It is extremely high, and it is dynamic also. This is followed by the accuracy, which we have just discussed. I think I have just I have mentioned greater than 95% in the right column and 80 to 85% in AI based detection. So this is one thing which I have just interchanged it. So just please, I beg your pardon for this. So we can say that accuracy is greater than 95% in AI based detection reaching to almost 97%, and in conventional method it is 80 to 85%. So this is in terms of accuracy. Now coming to the responsiveness. So responsive, the system has to respond accurately. So as I mentioned, in power systems, we cannot, wait for even for a minute whenever there is a particular detection or identification or isolation of faults are needed. We cannot rely immediately. It has to detect, it has to identify, it has to classify, and it has to restore it accordingly. So even in conventional method, it will give in nearly some a few seconds it will require, but it will give in some seconds, but again that time limit will be fixed. But as far as this AI based detection is concerned, it is less than a second. So we can say that within a millisecond it is going to detect, it is going to classify, and it is going to reveal the exact nature of fault. So that is why flexibility aspect is something which we can achieve in AI based detection as far as the responsiveness is concerned. Now this is followed by the computation ability. So of course, computation ability in conventional method is relatively low, but in AI based detection, it is not decent, it is actually excellent. So, whenever, as I have mentioned, I've been working with a few of the optimization techniques to, solve the particular virtual power plant problem, VPP problem. So, whenever I have used any optimization technique, it is almost, quintessential. It is required to mention that what is the computation time that particular optimization technique has consumed. So based on that, whenever we do any comparative analysis, since we are comparing conventional and AI-based detection, I thought I'll spend some few seconds on it. Whenever we are comparing any particular technique, in this case, we are comparing conventional-based approach and AI-based detection. So whenever we are comparing anything, that particular computation complexity is very much required to mention. So based on that only, it can be determined that how effective your particular selected technique or method is. Based on that only, we can we can justify that why we have, selected that particular optimization technique in that case. So computation ability is also excellent in AI-based detection as compared to conventional. And finally, the complexities which I have been mentioning, it is also limited in conventional method as it struggles to adapt to the changing grid conditions. And in terms of AI based detection, it is self adaptive, it is self learning. And also, one very important term which I want to mention is it is self healing. It is also self healing in nature. It can heal by itself. Once the fault is detected, it can heal it by itself. So that is why it has been mentioned as self adapted to complex scenarios. So again, we will talk about this, that how a conventional are very much outdated, and how new age AI based technologies are coming into the picture. So this, we I think already we have discussed. Delayed response, limited accuracy, and also it requires a regular tuning. If you don't tune the system, the conventional approaches cannot help you for a long time. But this new age AI method is something in which we can get real time response. So scheduling and dispatch is, power scheduling and power dispatch is something which we'll usually consider on a day ahead basis. So day ahead basis, as I hope that you all are aware that we are carrying out for a 24-hour time scale. That is why it is called as day ahead. We are already having the prediction of the power requirement on a day ahead basis. So why I am saying this is, as that particular scheduling approach is effective, but it is again we have to extrapolate its time scale so that we can have some glimpse of real time response. So if I talk about the day ahead dispatch scheduling, it is fine, it is effective. But if we can transform it into a hourly based scheduling, in which every 30 minute instead of 1 hour, every 30 minute it is going to update itself. Likewise, what if we can divide it into a 15-minute block? So if you see in 1 hour, it is going to give you the demand for almost 4 blocks. So 4 blocks in 1 hour will be equal to roughly 96, right? So 24 4s are 96. So some 96 blocks. So you know how this real time thing can be comparatively more effective as compared to the day ahead scheduling. This is followed by another actual real time scheduling in which we can consider, we can even extrapolate for 5 minute time response. So every 5 minutes, the system is going to update itself and it is going to give you the latest requirement, what is required. So that is why all those things we have to consider, and at the same time we have to see that that the system should not burden itself in terms of the complexity. That is why I am restricting myself to 5 minutes. Even we can go for 1 minute time scale also, even we can go for some seconds also, but then just imagine how much computational burden we are imposing on the system. So 15 minute and 5 minute is something which the researchers across the world have agreed upon, and they came with that particular regulation that yes, a day ahead hourly based scheduling and real time scheduling based on 5 minute time scale can be retained without burdening the system with additional computation complexity. So that is something with related to real time response. Now, also we can have some consolidated information in which the noises and uncertainty can be reduced relatively as compared to the conventional approaches. And this is followed by the auto adoption of new age based AI based technologies. Uh, so yeah, I think on my screen there is some red markings I am seeing. Madam, can you just tell me that what is the that something happened on the screen? Madam, are you there? Hello?
Yes, sir, I'm here.
Madam, can you see the screen? I think it is completely, it is red marked. Uh,
1 minute, sir.
yeah, yeah. Yeah, thank you. Now it is removed. So this is one image which I have taken in the slide, which is the general architecture for intrusion detection. It is just for the sake of discussion. That is why I have also given the source. It is published in Cluster Computing Springer Nature paper, recently published paper. I found some relevance with respect to this particular topic. So intrusion detection system, which I have mentioned in the very first slide. So you know these new age devices, which are IoT connected devices, in which smart meters are there, advanced sensor are there, embedded microcontrol based sensors are also there. So all of these are interconnected, and when these devices are interconnected, the data collection aspect will be comparatively more flawless, more fluent. And then these data are collected, which is followed by the pre-processing, which I have discussed in the previous slide. There is another block in which has been mentioned in this particular figure, which you can see as ensemble model. So ensemble model is something which is, combination of multiple decision. So if we are going by a particular opinion, if we are going by an individual opinion or individual decision, it cannot be more consolidated. But when we have a certain number of opinions, when we have a certain individual decisions, and when we can combine it together, we can have the feel of or glimpse of this particular ensemble modeling. So this is particularly very much relevant in terms of the intrusion detection. And once that particular detection is identified and classified, it is going to alert the control center, particular control center, which is followed by its necessary mitigation, whichever step the control system or the independent system operator, ISO, that is one term which is very important, which we'll use. That particular person or the command center is responsible to mitigate that particular fault once that particular generation has been fault has been alerted. So coming to the real world application, there are fault prediction in transmission networks. There are dedicated smart grid based fault monitoring, and also the protection of generator and transformers are there, and there is also some renewable energy resources based grid integration. Broadly, we will call it at DERMS, DERMS, that is it is expanded at distributed energy resource and management systems. So that is also particularly very much relevant in terms of the practical applications. And also coming to the potential, the AI model can detect the fault particularly relatively early. The early detection is possible by this advanced AI model. It can also bring some preciseness in the classification of fault, and as already discussed, it can give you the rapid detection in terms of, as compared to the conventional approaches. And it has the ability to adapt to the changing grid condition, and this is followed by its enhanced accuracy by analyzing the grid changing condition. It can always adapt continuously towards its grid changing condition. So also there are certain advantages in which we can have some high accuracy due to real-time processing, which I have discussed comprehensively, how real-time processing can give us comparatively more decent results. The downtime is also very minimum. It has the enhanced capability of restoration, also called as self-healing, and also it can adapt to the changing grid condition. So there are still certain barriers in AI detection. So the most important one, which is mentioned in this particular figure, is data scarcity. So data scarcity is the situation in which we require a lot of data for particular system to make a informed and precise decision. But due to the scarcity of data, it is relatively difficult to reach to a particular solution. So data scarcity, because I'll give one example, that whenever you want any data related to solar, particularly I'm emphasizing on solar, and also I will include wind. Whenever you want any data related to solar and wind, I think you will get that data online from a particular research paper. You can get from secondary literature, or you can get it from a particular company or website. It is available. Even you need not log in also with your particular user ID or registration ID. No, it is not required. You can download the data based on seasonal variation. Also, you can download data throughout the year. It is possible. But when it comes to a certain kind of data, like I'll mention one more source which I have mentioned earlier also, fuel cell, or a combined heat and power generation, CHP, you will not get that data. It is, the chances are very rare, because that is something which I personally have struggled during my research. You will not get the data. Even if you scroll some of the relevant research papers, they'll give some reference, but when you go to that particular site or a website or particular DOI link, that data you will not get, or at least it is going to ask you some money. It is going to ask you have to pay, then only you can access data, that too with limitation. You can only do it with your analysis. You cannot make it public also. So those things are particularly classified as data scarcity. So this is one of the most important barrier in AI detection. This is followed by cyber security protection, which I have touched slightly in my very initial slides, and this is followed by the true real time. So since we have already reached the 5-minute scheduling and dispatch window that we have reached, but still the true essence of real time is still debatable, because there is always possibility of further scope of improvements. That is also one issue, and this is followed by the throughout modernization which is required across grid setup. So these are some of the barriers in AI based fault detection. And if we talk about that, what lies ahead for artificial intelligence? So this is one thing, FL, which I have mentioned in the previous slide, federated learning, which is particularly suitable for distributed power system. As I have discussed, that there is a centralized structure for conventional approach, and there is a decentralized structure, which now rapidly we are moving toward that particular structure of power system. So it is decentralized, it is distributed power system, because power, even small scale power, is also coming utility grid. So federated learning is particularly suitable for this decentralized and distributed power systems. This is followed by the NIoTs, which I have mentioned. It is nature-inspired optimization techniques. So there are more than 300 to 400 optimization techniques which are currently available, including its conventional, the original version, the modified version, and various kind of advanced version of those particular techniques. So these optimization technique is also going to play a huge role in in this fault detection. This is followed by the DTs and decision trees, which we have already discussed a bit, and this is followed by the most important thing, interpretability of any particular fault. So these are the research, I think, past 5 o'clock, but I'll just take 1 more minute or 2 minute, madam, if it is possible, and I'll just quickly wrap up. So this is the research trends, AI in AI based power system, in which the very important thing, congestion management, how we can rectify the congestion management, because now we are aware that even apart from renewables, electric vehicles are also coming into the picture, and more EV adoption is encouraged by the government. Recently, one news I was reading day before yesterday, before while preparing this presentation, I came across that even people are sending their diesel powered Mercedes, which might have costed them more than 80 lakhs. They have somehow scrapping it in some 5 or 6 lakh rupees because of the new EV policy which has recently been adopted in Delhi. So this is something which is going to happen, and in the coming year, as the government of India is only initiating these initiatives, this fame to approach faster adoption and manufacturing of electric vehicle, more and more EVs are going to inculcate in the picture. And when it happens, the problem will be congestion management, because everyone want to charge their electric vehicle whenever they will reach to their home, from to their respective homes, after completion of their regular routine work. So how congestion management we are going to manage? So for that, a very robust network of charging infrastructure is required, which is also getting approved by various private players. So all these things are coming into the picture. So this congestion management is something which need to be taken care of. This is followed by the grid ancillary services in which voltage regulation, frequency stability needs to be taken care of, stability analysis, and hybrid generation and transmission and expansion planning is also very much active in the research trend. This is followed by the automation of power system, like how we can we can have a true modern power system in which the automatic self-healing or restoration can happen once the which has very specific meaning. So it has to be, the system has to be self-resilient and robust in nature. This is followed by the last one, which is electricity market exploration, and how we can participate in wholesale market, in which again the virtual power plant technology VPP is going to play a huge role. Because of that particular advancement only, even if you if you search for IEX website, it is Indian Energy Exchange website. It is our Government of India powered initiative only. You can get all those data, the intraday market data. It is not interday anymore. It is intraday. So inter means it is the difference between another 1 or 2 span of days. But intraday, we are bidding in the wholesale market in that particular economic dispatch block. So that is also very much trending. Those who are who wants to have some new essence or novelty in this kind of particular research, I think you can just go ahead with this. There is huge scope with it. And for this is followed by the trading and bidding strategies. These are some research trends which I want to discuss as far as AI are concerned. And finally, there is huge scope, ample of scope which lies ahead to explore this artificial intelligence-based advancement in power system applications to make it a holistic and self-resilient and sustainable modern power system. So with this, I will wrap up my presentation and
It's my
yes.
honor to introduce our dynamic speaker, Dr. Anubhav Kumar Pandey, currently serving as Assistant Professor in the Department of Electrical and Electronics Engineering at Dayananda Sahar College of Engineering, Karnataka. Dr. Pandey is a recipient of DST Inspire Fellowship and completed his PhD at Manipal Institute of Technology. With a strong background in engineering technology, he has published numerous Q1 Q2 journal papers, presented at prestigious international conferences, and serves as a trusted reviewer for top elsewhere and IOP journals. His research spans across virtual power plants, electrical vehicles, smart grids, power markets, and sustainable energy systems. He is also a technical committee member and has reviewed over 400 conference papers. We are delighted to have you join us, sir. A warm welcome.
Thank you. Thank you very much, madam, for my brief introduction. And
Thank you, sir.
yeah, I guess I'll share my slides now.